Hello everyone, welcome back to another GIS mathematics lecture video. And in this lecture video I want to continue our discussion on reduced row echelon form. And I want to tie it back to this idea of systems of linear equations. Now again, I want to stress that for this course we're not worried about the linear equation side of things. We're worried about the matrix side of things. But remembering that this relationship exists makes this idea that we talked about last time of elementary row operations make a lot more sense in terms of why we can multiply one row by a scalar, why we can add rows together, and why we can change the position of rows. Because we're not changing the underlying relationships that occur in the systems of linear equations that we have related here. So we talked about reduced row echelon form, and we've said that, hey, this is an extremely useful property for solving linear equations, and as a byproduct, right, we get all these other really cool properties. But what does it actually mean to be in reduced row echelon form? So let's go ahead and talk about that. Right, what does it mean fundamentally to be in reduced row echelon form? Well, it means sort of four things. Right? The first is that the first non-zero element in every row is a 1. Right? And this is often called a leading 1. We're going to look at some examples of reduced row echelon form matrices in just a second. All right. 2, each leading 1. Again, that's the first non-zero entry in a row, is to the right of the leading 1 in the rows above it. Three, right? Any row of all zeros is at the bottom. And 4, right? Any column with a leading 1 has zeros everywhere else, right? So these 4 statements, right? The first non-zero element in every row is a 1. We call this a leading 1. Each leading 1 is to the right of the leading 1 in the rows above it. Any row of all zeros are at the bottom. And any column with a leading 1 has zeros everywhere else in that column. Right? If these four things are true, then you have a matrix in reduced row echelon form. If any one of these things is not true, then you do not have a matrix in reduced row echelon form, okay? So let's go ahead and let's look at some example matrices, okay? Let's go ahead and start off with our with our 2x2 identity matrix that we've created in a previous video. All right, is this in reduced row echelon form? Well, let's go through our checklist. Is the first non-zero element in every row a 1? Check. Check. Is each leading one to the right of all the leading ones before it? So what does that actually mean? Right? That means that if this is a 1, right, the leading one has to be over here somewhere. And in this case, it is, so that's right. If there are any zeros, are they at the bottom? Well, in this case, there are no rows of all zeros, so we're good there. If a column contains a leading 1, all other elements must be 0. This is a 1, that's a 0. This is a 1, that's a 0. So this is in reduced row echelon form. You'll often see this written as RREF, reduced row echelon form. Okay, so let's go ahead and look at another example. Let's look at the example 1, 0, 1, 0, 1, 2. I want you to pause the video and I want you to think about whether or not this is in reduced row echelon form. Okay, hopefully you gave it a thought. If you came up with yes, you are correct. Let's go ahead and walk through our checklist and figure out why it is. So, first thing we say is the first non-zero entry in each row a 1? Well, check. This is a 0, so we go over. 1, check. Right? So the first non-zero entry in both rows is 1. We're good there. Each leading 1 comes to the right of the leading 1 before it. Again, right, this leading 1 is here, so that means that this one has to be somewhere to the right, which it is, so we're good there. All rows of zeros are at the bottom. Again, we don't have any rows of zeros, so we're good there. Then finally, if a column has a leading 1, all other elements have to be 0. So this is the leading 1 here. Look at all the other elements. They're 0, so we're good there. This is a leading 1, so we look at all the other elements. They're 0, so we're good there. Right? So this, even though these there's numbers here, these don't matter. Right? Because these aren't influencing the reduced row echelon form. So this is in reduced row echelon form. Okay. And again, you'll sometimes see that as RREF, reduced row echelon form. Okay. Let's look at one more that is 0, 1, 2, 3, 0, 4, 1, 2, 3, 4, 1, 5, and then 1, 2, 3, 4, 5, 6. All right, now I may have already spilled the beans, but I want you to pause the video and confirm for yourself whether or not this is in reduced row echelon form. Okay, so hopefully you did that. and hopefully you came up with this is in reduced row echelon form. But let's go ahead and walk through our checklist one more time just to confirm for ourselves. So our first thing is the first non-zero element in each row a 1? This is a 0, so we don't have to worry about that. This is a 1, so we're good there. These are all zeros, so we don't have to worry about those. This is a 1, so we're good there. And in this row, they're all zeros, so we don't have to worry about that at all, right? You can have zeros, but the first non-zero element has to be a 1. So we're good. Each leading 1 comes to the right of the leading ones before it. All right, so here's our first leading 1. So that means that our next leading 1 has to be to the right. Right, in this case, right, it's all the way over here. It's still to the right, so we're good there. All rows of all zeros come at the bottom of the matrix, which indeed in this case, right, we have a row of all zeros. They're down here, so we're good there. And then finally, for each column with a leading 1, all the other entries in that column are 0. So we have a 1 here, 0, 0, we're good there. We have a leading 1 here, 0, 0, we're good there. So this is also in reduced row echelon form, okay? So now I want to look at an example of a matrix that is not, right, I repeat, is not in reduced row echelon form. And this is going to be our last example. Right, and I want to look at this example of 1, 1, 0, 0, 1, 0, and 0, 0, 1. Right, pause the video for a second and see if you can figure out why this is not in reduced row echelon form. Okay, hopefully you figured it out. Let's go through our checklist. I'm going to go through it in a slightly different order because I want to make sure that the reason this fails is at the end. So first thing we check, does each row have the first non-zero element being a 1? 1, check. 0 doesn't count. 1, check. 0, 0, 1, check. So the first non-zero element in each row is a 1. We're good there. Each leading 1 comes to the right of the leading ones before it. So we are here, so we have to go to the right. We're good there. We have to go to the right. We're good there, so that's good. If it contains a 0, if it contains a row of all zeros, they have to be at the bottom. We don't have a row of all zeros, so we're good there. But then finally, right, if a column contains a leading 1, then all other elements in that column have to be 0. 1 leading 1 here, 0, 0, we're good. Leading 1 here, 0, 0, we're good. Leading 1 here, well, that's not a 0, right? So this is not, right? This is not in reduced row echelon form. And I'm going to circle this right here because this is our problem, okay? So hopefully you understand what reduced row echelon form looks like, how to identify it. In the next video, we're going to walk through how we actually go about converting a matrix to reduced row echelon form and how to determine if it's even possible to do that. So hopefully this makes sense, and if you have any questions, please reach out. Thank you.